Hi guys, hope you're fine and doing well. So today we will be discussing this problem from the Codeforces round 794, which is odd subarrays. So before moving on to the problem, in case you are new to this channel, you can consider subscribing it and pressing the bell icon so that you don't miss any of the upcoming updates. So let's get back to the problem. So the question states that we are given an array B, which is B1, B2 up till Bn. So we define the number of inversions as the number of pairs I and j of the integers such that I is less than j and b of I is greater than b of j. And we call this array B as odd if its number of inversions is odd. For example, the array that we're given is 3, 4, 5, 6, and 1. So the number of inversions is basically the first inversion where this is I and this is j, and moreover this element is greater than this element. So the total number of inversions here will be basically 3 comma 1, 4 comma 1. So these are basically the elements, not indices that I am writing here. 5 comma 1, 6 comma 1. So the total number of inversions here are 4. But in the question, it is given that we call an array B as odd if its number of inversions is odd. So let's consider if this element was 2. So now there was another inversion. So the total number of inversions now are 5. So now we can call this array as an odd. Next, we are given here an example where the elements of the array are 4, 2, and 7. And this array is called odd since the number of inversions is 1, which is basically 4 comma 2. And for this array the number of inversions is 2, which is 2 comma 1 and 4 comma 3. So this is not called an odd array. So next what we are given is that we are given a permutation of p1 p2 up till pn, and for the integers 1 to n. And what we are required to do is we need to split it into several consecutive subarrays, that may be just one, so that the number of odd subarrays among them is as large as possible. And then we need to output the count of largest or the maximum number of these subarrays that are odd. So the constraints of the problem are that t varies in the worst case from 1 to 10 to the power 5, and the length of the array is 10 to the power 5. So it is clear from here that we can obviously not do this question in O of n square. So we need to think of something like O of n or O of n log n. So now let's have a look at some examples. So let me just clear this out. Yes. So now let's suppose that we are given numbers something like 2, 3, 1, and 4, 6, and 5. So firstly, if we see that, if we consider this subarray, in this case, the total number of inversions is 2. So let's write this aside. So if we see that the total number of inversions are like 2 and 1, 3 and 1. So these are the elements that I have written. So here we have 2 inversions. But if we clearly observe is something is that if we want to consider only odd inversions, then we can just simply divide this into 3 and 1 and let this 2 be alone. So in this case, the total number of inversions will be 0, and for this case, this will be 1. So now let's see how can we approach to this problem in this case. So firstly, what we will be doing is we will create a max variable and initialize it to 0 and start iterating from the first index. So we will check whether this element is it less than this max or not. So because we are why we are keeping max here is because for the previous all array we just need to check that is there a maximum element or not. So in case the element is maximum, so this value can directly create inversion with this max element, and that too in the case where max is greater than a of I. A of I is the particular element that we are currently standing on. So if that's the case, so the total number of inversions can either be odd or even. So now previously just we saw that if there is a case that the total number of inversions is even, then we can simply just create it to odd by eliminating the other elements. So it is clearly possible. So we do not bother whether the total number of inversions is it odd or even, because even can also be converted to odd by just limiting the range. So the only thing that we will be checking is this condition that whether this max is it like greater than this particular element or not. So in case it is not greater, we will just update our max to this 2. And now we will be moving to the next element, which is 3. So now we will be checking whether this max is it greater than 3 or not. So again, it is not greater than 3. So we'll be now updating our max to 3. So now the updated max is 3. Now the next element that we will be moving on to is 1. So now we will check whether this max is greater than this particular element 1 or not. Yes, it is greater. So now what we shall be doing is we shall be simply also creating a variable like count that will keep the total count of all the odd subarrays. So initially it will be 0. So now here we will simply increase our count to plus plus and it will become to 1, and we will simply update our max to 0. So now we have ideally created this as one of the subarrays, but here the total number of inversions are even, so we can simply just again break that into two subarrays. So we do not bother whether is it even number of inversions or odd. We will just count it as 1 because in this case the total number of inversions is 0, and in this case the total number of inversions is 1. So ideally it will be contributing to only 1. So that is the reason we have increased the count variable to only 1. So now we again move to the next element, which is 4. Since the updated max is 0, so we will be checking whether this like max is greater than this 4 or not. Since it is not greater than 4, we will update this to 4. Now we will check for 6, whether 6 is less than this max or not. So that's not the case. So now we will update this to 6. And lastly, we will be moving on to 5, whether this max is greater than this 5 or not. Yes, it is greater in this case. So what we shall be doing is this count will again be made to plus plus, and now this count will be 2 because previously it was 1. So after incrementing it will become to 2, and again this max will be 0. So now the new another range that we got is 4, 6 and 5. So in this case the inversions is only 1, which is 4, 6 and 5. So which is only 6 and 5. So it is our choice that we simply want to like divide it into 4 and then 6 and 5, or 4, 6 and 5 as whole, because in the both cases the answer is that we are getting is 1. So the answer for this problem is 2. So 2 are the total number of inversions that are uh, possible, not possible, total number of odd subarrays. So now let's have a look at the code to this problem. So firstly, what we have done is we have simply taken the input for n and the array that we are given, and we have created a count variable and the max variable. So here we have applied this for loop where we are checking if this max is greater than the particular element that we are standing on. If that's the case, then what we shall be doing is we will simply update max to 0 and count will be increased by 1. Or else the case is that till now there is no inversion possible in the particular subvariant that we are dealing on. So we will simply update our max to the maximum of the max variable and the current element that we are standing on. So after that, we will simply just output the total count of all the subarrays that are on. So I hope you understood solution in this video. And if you appreciate my work, you can consider subscribing to my channel and giving thumbs up to this video. So let's meet in the next video. Till then, bye bye.